In this video, I'm going to show you how to calculate and create a confidence interval when sigma is known. Now we're going to use a 95% confidence interval in this example, but you'll be able to set whatever confidence interval you will if you follow these steps and you create yourself a template like we're going to do here in a second. Everything that we're going to be doing here, we're going to do in Excel. So if you recall, the formula for the confidence interval with a known sigma, this is a very big difference between if you're using the student t distribution, is sigma, and we are using a z alpha over 2. So let's skip over to our data set. This is our data set. Now we need a couple of things from this data set. Primarily, we need our x bar from here. And our x bar is going just to be the average of this, column A, so 9.76. And we have to be given the sigma for the entire distribution, for the entire population, or we can't use the sigma is known. So the sigma for this operation is going to be 3.76. We also need to know the number of observations. Now there's an easy command in Excel that allows us to count just the number of observations, and it does ignore the header. I'm going to say n, and this is equal to count of the values here. And the final thing we need is our z alpha over 2. Now, when we're using the known sigma, there are tables that allow us to just quickly get these numbers, but we're going to calculate it here because I want you to have a full template to calculate the confidence interval. So confidence interval here, we're going to do a 95% confidence interval, so 0.95. We're going to do this in a couple of steps. So our other piece that we need is our alpha over 2, this part right here of the z alpha over 2. This is going to be 1 minus the confidence interval divided by 2. Oops, shouldn't put equals there. There we go. So this equals 1 minus, notice how I'm actually clicking on the cell here to make myself a template, divided by 2. Okay. Now I have everything I need to calculate the z alpha over 2, z alpha over 2, and I use the norm inverse function to find the z alpha over 2. Norm inverse is taking the area under the curve that corresponds to 25% from the left side. Okay, just to draw a quick picture of this, I have a standard normal curve centered around 0. The area under this curve I know is 0.025. I'm looking for this number right here. I need the mean. The mean is always 0 for this computation. The standard deviation is 1. And this is my z alpha over 2. But notice Excel gives me a negative number. I don't want a negative number here. So I put a negative in front of this, and it gives me my correct z alpha over 2. You're often going to see this expressed for 95% confidence interval as 1.96. Finally, we can calculate our lower bound and our upper bound using the formula that I showed you previously. This one right here. Do this in multiple steps if you're more comfortable with that in Excel, but I'm going to do it in one step. So this is x bar minus z alpha over 2 times sigma divided by the square root of this number. Now, you can also add the square root of n up here, and I do that sometimes, but right now I didn't add that, so I need to do the square root of n. So all this, I'm going here and copy. Don't drag and drop. Excel doesn't like it when you drag and drop and you want to keep the same cells. So I'm just going to paste that. But I have to change something in here. I have to change this to positive. So what is this telling us? It's telling us that I am 95% certain that the true mean of the population from that this sample is taken from is between 8.4 and 11.1. The great thing about creating yourself a template, what if I want to change this to a 92% confidence interval? 0.92, bam, I got a 92% confidence interval. What if I want to change it to 99.9? I can do that very quickly. I can also change the number of observations in the standard deviation. Create yourself a template. It'll save you a lot of time.